All right. So today, like I warned before, we are reviewing how to solve quadratics. Now, yes, yay, right? Because sometimes when we're solving similarity problems, you are going to be multiplying x by x and get x squared. So we do need to remember how to solve when we have x squared. Now, what is a quadratic? I don't really want to be hearing anything from Algebra 2 people, though, because you guys should know this like the back of your hand, right? Hopefully.
No.
Hopefully. What is a quadratic? The exponent is what? Yes. Okay, so up until this point, we've been working with linear equations, which means that our leading terms, x, is just raised to the power of 1, right? It's just 1x. A quadratic, however, the leading term on a quadratic has an exponent of 2. It is x squared. So, in standard form, a quadratic equation is y equals ax squared plus bx plus c. Now, if I'm looking at this quadratic, how do you solve it? I don't want to hear from Algebra 2. How do you solve? What's one? There are two ways. What's one way you solve a quadratic? You can use the quadratic formula. That's the second line here. Quadratic. Yes, exactly. I never learned that, but I've heard people sing it. And what's the, oh yeah. And then what is the other way to solve? Starts with an F. Factoring. So you can either factor or you can use the quadratic formula. Now, in order to do either one of these things, what does your quadratic have to be set equal to? 0, yes. And when solving, you're looking for the solutions. What's another word for a solution of a quadratic? What's another word for solution of a quadratic? The solutions are the one starts with a Z. Zeros, yes, the zeros. Or the second one starts with an R. Roots. There's also a fourth one here. When you're thinking about a quadratic, the solutions are where? On a graph. On the x-intercepts, they can also be called. The x-intercepts. Good. All right. So I know that you may have learned how to factor using a different method than I use, but most of the Algebra 2 teachers next year are going to teach you this way. So that's what I'm going to show you. Yes?
How do you do it?
X method. What? It's that. What's what I saw, yeah. Miss Montague does the same thing as I do. I think Mr. Stevens does it a little different. That's the only thing. So, here, when you're trying to factor, you do the X method. This is where you draw an X. And your top term that you put in the top of the X is your A times C value. And in the bottom, you put your B. And then these two side numbers are two numbers that need to multiply to get the top number, but add to get the bottom. So these two numbers need to multiply to get the top, the A times C, and add to get your B value. So let's try it. We're going to try to factor. Now, When I say a in this equation, what am I talking about? No, I'm not talking about m squared. No, I'm not. What am I talking about? What is the number in front of a variable called? Coefficient. I'm talking about the coefficient on m squared, which is what here? 1. And then your b value is what? 1. And your c value is? -12. Good. Now, we're not really practicing this, but before you factor, what should you always look for? Yeah, check if it's equal to 0. Before you factor, you always check for a what? Not denominator. You look for a GCF, always. We're not going to go way too in-depth with this today, right? It's just a bare skimming of what solving is. But remember, next year, always look for a GCF first. These do not have a GCF. They don't have a common factor. If the 12 had an m, yes, I could take out an m. But it doesn't, so I can't. Okay, so we're trying to factor. First thing you do is draw your x. And what goes up top? A times c, which is 1 times -12, which is -12. And then what goes in the bottom? B, which is, what is your b? 1. So, now what we're trying to do, remember, is find two numbers that multiply to get you -12 and add to get 1. Sometimes it's hard for you to think of this in your head, so don't be afraid to list out what are the factors of -12. And what is a factor again? Something that multiplies times another number to get you -12. So what are two numbers that multiply to give you -12? Don't give me the right ones first. 1 and -12. What else? 6, -2. Do any of these add up to give you 1 yet? No, so we need to keep going. What else? Let's do, does -4 plus 3 add to give you 1? What about -3 times 4? Does that give you -12? And does it add to get you 1? So those are our two numbers we're looking for. -3 times 4. Yes. Now, like Sean just said, this is not our final answer. We wouldn't write this and say, okay, those are the factors of our quadratic, right? There's not even x in there. Clearly, those can't be the two things that multiply to get you your quadratic. What you have to do is put x in front of the values you found. So x minus 3 and x plus 4 are the factors of the quadratic. For two answers. So, yes, in order to find the solutions, which a solution is x equals something, right? What we can do here is set each one of these individually equal to 0. So x minus 3 equals 0 and x plus 4 equals 0. And then how do we get x by itself here? You add, you solve for x. You add 3 over. So x here is what? 3. And then what do you do on the other side? You subtract 4 over. So x is equal to -4. These are our two solutions to the quadratic. Any questions so far? This is kind of just like a quick and fast demonstration on how to factor. So, good question. When you are solving a quadratic, you should always end up with two answers when you're factoring. Now, sometimes when a problem is not factorable and you have to use the quadratic formula, sometimes you'll end up with no solutions and sometimes you'll end up with one solution. We'll get to that once we get to the quadratic formula, okay? Right now, I want you to do the second example over here. Go ahead and try it. Oh, I'm seeing a lot of good answers here. What do you do first? Draw your x. Okay, what should you look for first? Always look for a GCF first. Clearly, is there a GCF here? No, so we can, yes, create your x. Now, what goes up top? A times C, which is negative 60, and then the bottom? B, which is negative 4. Good. Now, when you get to Algebra 2, your Algebra 2 teacher is not going to sit over here and draw out the factors, unfortunately. We kind of assume that you have a good understanding of factors, and they're just going to ask, okay, what multiplies to give you negative 60 and adds to give you negative 4? But just remember, if you have a hard time thinking of factors, you can always write them on the side like we did, okay? Okay, so what does multiply to give you negative 60 and add to give you negative 4? Negative 10 and what? 6. Good. They multiply to give you negative 60, but add to give you negative 4. These are the two numbers that are incorporated into our factors. X minus 10, x plus 6. Now everyone understands that these are termed factors because when we multiply them, they give us the quadratic. How would we multiply these? FOIL, double distribute, box method, whatever is your cup of sugar here. You can multiply to get the quadratic. Right? Okay, so how do we now get our solutions? Whoa. Ah, yes. Set them each individually equal to 0. So x minus 10 equals 0 and x plus 6 equals 0. So here, our solutions are x equals 10 and x equals negative 6. Any questions? Yes.
Why do you have to solve them? You can just know what's going to be the opposite.
So when I first started teaching Algebra 2, I said, yes, okay, flip the sign. However, I noticed that when I said flip the sign to get the solution, almost half of the students were flipping the sign to create the factors because they did remember flip the sign, but they couldn't remember where. So I do not like telling students to flip the sign because they're not really understanding, okay, what math is going behind flipping the sign. Well, you set them equal to 0, and that's how you get the flip sign. No, I wouldn't count it wrong. Sean, could you tell that I didn't just flip the sign here? I wouldn't be able to tell. I wouldn't be able to tell if you set it equal to 0. If I didn't have this written, I wouldn't be able to tell if you set it equal to 0 or just flip the sign. It's the same math. You just have to remember, don't do it here. Do it here.
Yeah.
Okay. All right. So now, guess what? Not all quadratics are nice and pretty and have cute little factors. Unfortunately. Sometimes they're these really, really ugly looking decimals or radicals. Yes?
So in Algebra 1, we all get on the calculator. Like, are we going to have to do it like on paper?
Yes.
Oh, no. Teacher taught us nothing.
So like you didn't write it out, or?
She literally just told us how to do it on a calculator. That's all.
Okay. So it's okay because it's the same premise, right? So clearly here, is there a number? Shh. Is there a number that multiplies to give you 20 but adds to give you negative 10? You should always try to factor first. So is there a number that multiplies to give you 20, adds to give you negative 10? 4 and 5, no. 1 and 20, no. 2 and 10, no. So clearly this does not factor. That's when you turn to the quadratic formula, which is this big long thing. Now, unfortunately, I keep forgetting to fix it. This should be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now the hardest part about this is making sure that you're doing everything correctly. It's not hard logically, it's hard computationally, okay? So, all I'm going to do is take these A, B, and C values and plug them into my quadratic formula. So, what is my B value? Negative 10. So I'm going to write here negative 10 plus or minus the square root of negative 10 squared minus 4 times A, which what is A? 1. What is B? I'm sorry, what is C? 20. All over 2 times A, which A is 1. Now, what math here do you think I'm going to tell you to do first? Always the number inside of the square root. That's the math that needs to be done first. So, 10 squared is how much? What is 10 squared? 100. And then what is 4 times 20? What is 100 minus 80? 20. So it's 10 plus or minus the square root of 20 over 2. Now, just quickly, let's go over this. This 20 is a positive number. So how many solutions are you going to end up with? 2. If this number inside the radical had been a 0, how many solutions would you end up with then? 1. If the number inside the radical had been negative, how many solutions would you end up with then? If inside the radical it was a negative? None. And these are actually called blank solutions. Starts with an I. Algebra 2. Imaginary solutions, okay? You will be dealing with that in Algebra 2. We're not dealing with it now. This number inside of the radical is called your discriminant. It tells you how many solutions you're going to end up with. Now, do you think I want you to leave it like this? What do you think I want you to do? Do what here? Simplify that square root 20. So, over here, what does 20 split into? 10 and 2. What does 10 split into? Do I have pairs? I have a pair of. So what goes on the outside? 2 goes on the outside, and the leftover 5 goes on the inside. Good. So this is actually 10 plus or minus 2 square root 5 all over 2. Am I done? Why am I not done? You can leave it plus or minus. That's fine. Some teachers prefer it to be split. It's fine if you put plus or minus. It's understood that there are 2 solutions here. You need to simplify all the whole numbers. You need to see if they have a common factor. Do 10, 2, and 2 have a common factor? They all have a common factor of 2. So take a 2 out of everything. What's 10 divided by 2? 2 divided by 2? 2 divided by 2? So my actual answer here is 5 plus or minus the square root of 5.
Yay!
And that's 7
Guess and check. Guess and check what? Guess and check what? Like, you're going to...
Numbers. That's what we do. That's what I was do.
How can you guess and check numbers?
I know, there's a way for it.
Oh my God, I'm having a heart attack.
Algebra 1 teacher. What is this?
I'm gonna come back to you about that. I'm gonna come back to you about that.
You can plug it into a calculator.